Hello, everyone. Today we are going to be talking about the shape of data distributions. I know we're not at school today, so this is a good one. It's kind of talking through. It would have been a lot of writing, so you should be very glad that we'll be able to do this with you listening. Make sure you pay close attention to this because it'll be information we'll use over the upcoming days also. So some big keywords we want to keep in mind here are distribution, cluster, gap, peak, symmetry, and skewed. They're all listed up here, okay? So you might need to rewind a few times to be able to explain some of these. Distribution is the shape, shows the arrangement of data values, so it's how it's spread out. Cluster is data that are grouped closely together. So my cluster on this example here would be 10, 11, and 12. They are clustered together, okay? Gaps would be numbers that have no data values. I have a gap in 9 and I have a gap at 13. I have to include those numbers on my line plot, but I don't have values for them, so that's why they're gaps. Okay. You can also talk about peaks, which is the most frequently occurring values or the mode. So if I had kind of a wavelength here, it showed my um, peak, the top part is that peak or would show my mode, okay? And then also symmetry is when the left side looks the same as the right side, okay? So symmetry here. If I looked up at this one up above it, it's not exact, but my symmetry is pretty close. I am one data point away from it being completely symmetrical. So that would have pretty good symmetry on the one up above also. And then we can also talk about skewed, if data is skewed, when the data points cluster more toward one side than the other. So negatively skewed is if the long tail is on the left, okay? So this data is skewed to the left. It's where I don't have data points because that's where it's lacking information, which kind of seems backwards. You would think it would be skewed right because all of my data is to the right, but it's opposite of that. Where I'm lacking the data is where it's skewed. This is skewed to the left or negatively skewed. And then my other graph here is positively skewed or it's skewed to the right because I don't have any data values here on the right. All of my data values here are on the left. So we're going to describe a few of these. It's going to be you just kind of following. You don't have this paper here. I have it as a material in our Google Classroom. If it's something you'd want to access to, I'm going to leave my answers on there, but it's not something you'll have to write down. So we're going to describe the shape of the distribution, consider words. We're going to use words like clusters, gaps, peaks, symmetry, skewed, and outliers, okay? So if I look at this data, I don't have, I'm going to do distribution first. Let's see, my first quartile is the same as my fourth. My middles are the same. So on this, if I was describing it, data is spread evenly for its distribution. I know you're just seeing me write it, but you need to make sure you're paying close attention to focus on this. It's all spread out evenly here for the distribution. Gaps, peaks, and clusters cannot be identified. That's because I can't tell if there's any high points because on a box plot, these are things that I'm not able to see. And then I can put that there are no outliers. Outliers on a box plot, which we finished yesterday, are shown with that asterisk. Okay? There are no outliers. Then my next graph here, I have, it's more of a histogram. If I was going to describe the distribution, if it's symmetrical, if I draw a line down the middle here, my values are not the same. It's really not even close. It's kind of up above here. So the data is not, oops, come on, let's type for me here. The data is not symmetrical. It is not symmetrical. There are no gaps because there's no empty spaces here in it. The data has a peak. My peak is like my highest point. If this is kind of 200, this is probably around 250 at 250. And there are no outliers because I can't tell of any number that's super huge compared to the others. Okay? Now, my temperature here in my last graph on this first section here, if I'm looking at my distribution, I'm going to draw a line down the middle, which would be at 20. My data is not the same on each side, so the data is not symmetrical. If I wanted to explain, because the left side does not look like the right. We're going to use this word symmetrical later on, okay? There are gaps between 19 through 21. There are no numbers between there, 19 and 21, because they have no values. There are clusters. So remember, clusters are closely grouped together. There are clusters between 16 and 18, and also 22 through 25. If I'm looking for my peak, it's my highest point. 22 is the peak, and there are no outliers. If I'm looking at the information, there's no value that's a lot greater than others. Okay, we're going to get into some questions here for you. When we have to determine measures of center and our spread here, we have to ask ourselves first if the distribution is symmetrical. If the distribution is, yes, symmetrical, that means it's the same on each side, like my box plot here, then I would use the mean to describe my center or my middle area, okay? And whenever I have to do the mean to show my spread, I'm going to use mean absolute deviation, which I know is something we have not done in a long time, which is why we will review it also, okay? If my data is not symmetrical, we're going to use the median instead, that middle line in the middle, okay? And then we will use interquartile range, which is our IQR. So there's different ones that we will use here. If it's symmetrical, mean, we have to use mean absolute deviation. If it is the median, then we will use interquartile range. So I'm going to ask some questions here. If my data is symmetrical, what do I use to describe the center? Now, if it is symmetrical and I'm going to use the mean, what do I use to describe the spread of my data? Okay, you should have said mean and mean absolute deviation. If my data is not symmetrical, what am I going to use to describe the center? Okay, that should have been the median here. And what will I use to describe the spread of my data if it is not symmetrical? You should have said interquartile range, or the IQR. So we have two more to practice here with. On this graph, let me draw my line kind of down the middle here, 15-ish. Does my data on the left side look like the same on the right side of my dot plot? Okay, you should have said no, because I have a whole bunch of data points here and none over here. Is my distribution symmetric? Is it spread out evenly? No, you should have said no, because I have all my data clustered together and then one number over here. Is there an outlier? You should have said that the outlier was 19, because it is much farther out than the rest of my data, okay? What are the most appropriate measures to use to describe the center and distribution, and then explain your response based on the shape? So if I'm going to do this, I'm going to look up here. It was symmetrical? No. So I'm going to use median and interquartile range, okay? So the data is not symmetric, and there is an outlier of 19. The median and IQR are appropriate to use. So now below, you're going to do that, okay? So listing these numbers out in order. I'm going to pause my video so that I can write them out in order here. Okay, I want you to look at the numbers that I have written out for you in order from least to greatest, and I want you to find the median. Since it is not symmetrical, what is the median of this data? You should have had that the median is 12, because it's my middle number here. So since I'm doing the median, if you remember from up above, if I'm doing the median, I have to find my interquartile range. What is the first quartile? You should have had that the first quartile is 11. What is the third quartile? By finding the middle of my second half, you should have seen that the third quartile is 13. So remember, if I do IQR, the IQR is, what is the IQR? I take quartile 3 minus quartile 1. So the IQR would be what? You should have determined that the IQR is 2. So if I'm explaining this, the data is centered around 12 states, and the spread of data is around 2 states, okay? Because it's centered around this 12, but it's spread around 2 different. I know I have an outlier here, but the most of my data is spread around those 2 states. One more with several kind of different parts here. Okay. I'm going to draw my line down the center of my data here. Does the left side of the data look the same as the right side of my data on this line plot, dot plot? You should have answered yes, that the data looks the same on each side. They are symmetric. So is the distribution symmetric? Yes, you should have said the distribution is symmetric again because I had the same numbers on each side. Is there an outlier? No, you should have said no, there is not an outlier because I do not have any data value that is much greater or much less than the rest of my data values. So what is the most appropriate measure to use for the center and the spread of distribution? If I look up above, remember if it is yes symmetric, I'm going to use mean and mean absolute deviation. So the distribution is symmetric and there are no outliers. The data is centered. The data and spread should be determined with mean and mean absolute deviation. So we're going to do that. So now we need to find the mean of my data that I have here. I'm going to go ahead and pause my video and write this out so it's a little bit easier for you to see. All right, I have written these numbers out. I'm going to read through them one time to make sure that my handwriting is not too hard for you to read, okay? 25, 26, 26. While I'm reading these, let me rephrase this. Get out a calculator because you are going to find the mean. So that means you have to add up all these numbers and divide by however many there are. So my numbers are 25, 26, 26, 27, 27, 27, 28, 28, 28, 28, 29, 29, 29, 29, 30, 30, 30, 30, 31, 31, 31, 32, 32, 33. So what is the mean of this data? You should have gotten that the mean is 29 years. If you add up all those numbers and you divide by however many there are, you will get 29. I did it on my calculator as well. And then the spread of distribution is the mean absolute deviation. Okay, remember, mean absolute deviation means that I am going to take the mean and I'm going to subtract it from every single one of these data points and then find the absolute value of that and find it again. So I'm going to write that out for you. All right, so I have this written out for you. You are super lucky that I wrote out all of these numbers. I'm going to get you started on it just to remind you, because I know it's been so long since we have done mean absolute deviation. So I took every single one of my data points, that's my first numbers, minus my mean, which was 29. And remember, these lines that I have here are for the absolute value. So 25 minus 29 is not -4, it's just 4. 26 minus 29 is 3 because it's absolute value. Sorry, that's supposed to be a 3. 26 minus 29 is again 3. So you need to write down all these numbers, okay? Subtract all of these numbers out. Remember, once you find out all of these differences, once you find out what all these totals are, you find the mean of that data. So then you add up all of these differences, and then you will divide that by 24 because there are 24 different data points. So what is the mean absolute deviation of my spread of data? When you found all of these differences and then you divided by 4, you should have gotten that the mean absolute deviation around a center is about 1.7 years. Great job, and thank you for working so hard on this. Make sure that you have your IXL GG23 completed. Ask me to join a Google Meet or email me with screenshots so that I can help you get through these. My final question is going to be if you have completed your IXL GG23. If you mark yes or a no, it just kind of keeps track here for it. Mark yes. It may mark it wrong on it, but I will go through, and as long as you give me an honest answer here, you will get it correct.